So that would be cool stuff. Let's see if we can find the interview questions that I was doing before. Interview questions. Here we go. Looks like a good Indian brother of mine. Well, I'm just guessing from the name. Oh, I see him. I see him. Confirmed Indian. Well, I guess he could be from Bangladesh, Sri Lanka, or Pakistan. But I love all them too, so it's all good to me. This dude researched the hell out of his questions and answered. Whoever this guy is, what's your Sudhir Jonah? Dude, props. Excellent work. Excellent research. You made that Java site that I was showing look so bad. So let's see. We did possible ways to create JavaScript, the prototype chain, difference in call, apply, and bind. Let me just go through this again without the code, but telling you. Ways to create objects. You can use an object literal, which is just curly braces. You can do a new object and then give it curly braces. So it's basically the same thing. You can call object.create. It's a lot of different ways to create objects. I pretty much only use object literals. I don't see a big reason for anything else. Prototype chain. JavaScript is a prototype language. What that means is you create an object and then you extend that object to another object. Or you create an object and then you extend the properties of that object to include new functions. Each object has its own prototype. It's not like a class. Classes don't take up space. They're abstract. In JavaScript, prototypes are actually real things. They take up space. Each prototype can have a link to another prototype. And that's how we do inheritance with prototypes, but I don't really do that. I generally do composition instead. Okay, so what is the difference between call, apply, and bind? Call and apply are basically the same thing, except one is going to take your arguments as like a chained argument list, and apply takes an array of arguments. It's really the only difference. You can destructure one or restructure the other and get the exact same result. Bind works differently because call and apply both work on an invocation, meaning the function's already called. Bind gives you back a new function that you can call whenever you want. So it'll have like the state of the object plus this new context that you're giving it. Bind, apply, and call are mostly used for binding the keyword this, and I don't use the keyword this as much as possible. It's one of the reasons why I don't write ES6 classes. As soon as you put the keyword this in it, as soon as you put the keyword new in it, there are certain things that you can do in JavaScript, and as soon as you do it, like your JavaScript just goes to hell. What's JSON's common properties? JSON is just a format that will serialize JavaScript objects into a string so that it can be passed over a network boundary, used as data, whatever. And common operations are like stringify to turn JSON into a string, or a JavaScript object into a string, which makes it JSON. And then parse, which is going to take that JavaScript object string and turn it back into a JavaScript object. These three questions we did, they're all really one question. What's the difference between, or what's slice do? Slice is going to like return a part of an array out. It doesn't modify the array. Splice returns an array part out, but it modifies the array. The difference between slice and splice, one modifies the array, one doesn't. How do you compare object and map? How do you compare object and map? By map, I'm guessing they mean a map, like a weak map. Okay, objects are similar to maps in both. Okay, so yeah, they're talking about a weak map. You can retrieve the keys, retrieve the values, delete the keys, detect whether something's stored in a key. Objects have been used as maps historically, but there are important differences. Well, if it's a real map, then like the ID, the key has to be, it's a specific thing. It's a symbol, and generally it's a hash. Generally it's a hash map. When you're talking about a weak map, a strong map, it's a hash map. It means the keys are hashed. Which means they would be ordered, which like there's a whole bunch of things that are differ. So how do you compare an object and a map? I guess what they're saying is like if you have like an actual object, how do you compare it to an actual map? So I guess we'd have to create both, right? We need to create a new folder here. Do I have the interview question? I don't. Okay, fine. Make dir JavaScript interview questions. No, I don't use spaces, and I'm going to cd into that with $_ which is just going to repeat the last argument that you gave. Code dot. Yet another code editor, and we're going to open this one up. We're going to call this one day2, and we're going to go in here and create a new file. Just call it index.js. JavaScript, baby, JavaScript. All right, so we got an object. This object has a key called color, and it's blue. And it has an _ ID, and that is a 1, 2, 3, 4. 4 zeros and a 1. Okay, so we have an object. We can create a map. We have to create a new map. The new map constructor, I believe, can take an object. So let's just run this. Node day2 index. Apparently, you can't just pass it an object. Object is not iterable. Therefore, you cannot. Okay, so. Okay, fine. Maps. What does a constructor look like? Nope. That's the map I use. Don't want the array map. We want the weak map, the strong map. We don't want the set. We want the map. Here we go. Yeah, you have to do it completely imperatively. Yeah, this is one of the reasons why I don't use map. I'm not a fan of imperative libraries. Okay, so you create a map, and then you'd have to do map.key. Actually, map.addKey, map.set. So map.set is going to take our key that's going to be color. And that color key is going to have blue. Actually, you know what we could do is we could just say obj at the key of color. Let's do the same thing for ID. All right, so now we should have a map and an object. All right, so we can't do something like this. Well, of course we can't. It's the triple equal. It's the 3 equal. Always going to be false. They're different objects. They're different types. They're different prototypes. Everything about them is different. What if we did a double? I hate doubles. I don't use doubles. But what if we did that? It's still false. So even JavaScript is like, I don't know. So how can we compare these two? We need to make sure that the keys and that the values are the same. We don't really care about anything else. Like, okay, so fine. How do we do that? Let's pick one that we're going to start from. We could start from the map. We could start from the object. It really doesn't matter. We can't map over it because it has key values, right? But what you can do is object.keys, map over the keys. So then you get a key. We could do like the entity where you could get, sorry, not entity, entry where you can get the key and the value, but you can just call object, you know, at the key and you get the value. So I don't actually like using entities all that much. So we're not gonna map over these. We need to say all, which is every in JavaScript. So we're going to go over all those keys. We want to make sure that all of the keys match up. So if we returned object at the key and we tried to do a comparison, actually, let's compare the key and the value. So the key should be equal to the map at the same thing, right? So our map.get at the key. Let's do one and then the other. And the key is key. But that's not going to get us the key for a map. That's going to get us the value. Okay, fine. Let's compare the value, and then we can compare the key sort of implicitly. Okay, so if we run this, what do we get back? We get back a false, we get back a true. So if we map over each of these and we're checking the values for each one, if they're all the same value, we're checking the key automatically. Like the key is checked because we're going to check each one of these, and every single one of these has to return. What if we change it to a map? Well, you get a true because there's two values in it. Okay. What if you choose a filter? Okay, so you get the two keys that matched. Okay, and if you choose an every, it's like a filter, except that it's only going to return if all of them are true. And because they are, you get it. And so you could say that this is one way that you could compare a map to an object. And of course, if you're watching on YouTube, if you're watching on Twitch, and you think that you have a better way of comparing an object to a map, certainly let me know. But this is the way I would do it. This is very functional. If this map was huge or this object was huge, then maybe you wouldn't do an every. Maybe you would switch it to a for loop. But that'd be some very convoluted code. All right, one of my favorite questions. What is the difference between the double equal and the threequal? The triple equal or the rope operator? Double equal sucks and triple operator doesn't. No? You need more? Double equal will do coercion based on like what JavaScript thinks things should be when they match up. Triple equal says, I'm going to let the programmer decide how to do the coercion, comparison, etc. What are lambda or arrow functions? Well, they're just functions. The only difference is that an arrow function is also a expression. It's an expression. An expression can be assigned to something. Functions, in the traditional sense, can't be. You can assign a pointer to a function to something, so it's a reference. What else? Arrow functions or lambdas can be used to bind the context of this to the parent object because they're anonymous. They don't have, there is no this inside of anonymous. If you call this inside of anonymous, it's going to look up above the chain and it's going to grab the thing that's not anonymous above itself, basically. What is a first class function? What is a first order function? Back to tricks. Okay. A first class and a first order or a higher order, these are all the same things. The concept is that in JavaScript, you can pass a function to a function, and you can return a function from a function. And you can compose multiple functions together with currying so that each function just uses a single argument. All of these things are properties of first class, first order, higher order. Let's see what they say. Functions are first class objects means that functions are the language treated like any other variable. Right, exactly. They can be passed as arguments, which I just talked about. They can be returned, I just talked about. First order is a function that doesn't accept another function as an argument and doesn't return a function as a value. Wait. First order is a function that doesn't accept another function as an argument and doesn't return a function as a return value. I'm not sure if that terminology is correct. Much less in JavaScript, but in general, I don't think that's correct. Right. See, first class function have functions that are like any other thing. In fact, look, this is what he copied for first class. First order function probably is going to come from the same place. Actually, first order doesn't seem to even exist. All right, let's ignore that one. That might be something that is cultural or to his area. Now, higher order function is the exact same thing as before. If you read this and you read this, it's the same thing in different language. A higher order function or a language that supports functions as a first class just means that they can be passed. They can be passed as a value, essentially. They're still passed by ref, but you can pass them directly. You don't have to create pointers. Like in C++ or C, you'd have to create a pointer to a function and pass the pointer. In Ruby, you can't pass a function at all. You have to create a special lambda construct, put the function call stuff inside of the special lambda construct, and then pass the special lambda construct, because in Ruby, functions are not first order. What is a urinary function? Let's actually go back to the question so that we can't cheat. Urinary. My top button. Whatever. I'll just scroll like an old man. I'm not a boomer. I'm an Xer, but whatever. Nobody talks about Gen X. And Gen X doesn't necessarily talk all that much to anybody else. We're just busy getting shit done. We built the internet. We're still building the internet. Everybody else is freaking out and you know, they're on this side or that side. It's boomers pointing at millennials and zoomers pointing at millennials and millennials pointing at the boomers. Nobody seems to even notice us Gen Xers. It's really sad because that phone that you have, we built it. The internet that you have, we built it. Those web browsers that you have, we built it. I'm at the end of Gen X. I'm very happy that I'm in Gen X and not another group. I had to do things myself. I couldn't just click a button and have code. I had to learn how to write code. Also, if you're given the option to just click a button to write code, just don't take the option. Just say, no, I'm going to work on my craft because my craft is what makes me money. Let's see. Pure function, blah, 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 blah. Okay, urinary function. What is a urinary function? Urinary function is just a function that takes one argument. That's it. So what is currying function? Currying function is where you can break one function up into a bunch of calls. What was this one? This one was rename, compare, map, object, create a new one. This one is currying. Okay, so you got unary 1. It takes A. You got unary 2, unary 2, it takes a B. You can compose those two together using composition. And there's ways of writing this code dynamically so that it can do it without you doing this directly, where you can compose things with a higher order composition function. So what happens if we pass those in? Well, we could do the cheap way, right? We could just call urinary 2. That's going to give us our first value. That first value is going to then come back and be passed into our urinary 1. Excuse me. So if you call this console.dir and you say composition and you give it 1 and 7, undefined. So this is going to return something. This is going to return something. Okay. These are urinary functions, but they're not really doing anything right now, right? What if this one was an add function? What if an add function took an A and a B? So we got an add. We can pass it a 1 and a 7, say. And we're going to do A plus B. So we get our 8, that's what we were expecting, but we're taking 2 arguments. How would we do this so that it takes 1 argument? Well, one way to do it is to give it the A, and then we can have another one that gives it the B. So if the B doesn't come in here, how do we get it? Well, add can return a new function, right? That new function can take the B. Now, this starts to freak people out when they see it written like this. So let me just write it in a way that you guys won't freak out about. So you got add. Let's call this the adder. The adder is going to take the initial argument, and it's going to return you. It's going to return you another call. What is the other call? The other call is B. Then it returns you A plus B. How does this work? we can't just call this, because it's not how it works. Our function comes back. Okay, so we could say adder dot add. What if we did something like that? What just happened there? Oh, I didn't name the inner function. Why does that work? I know people are probably looking at that and go, what? Why is there 2 parentheses? This is just functional programming. This is currying. Let's say we had another one. We had a C. If we were to call this now, we're going to get back the function. We're not getting back the actual thing. We'd have to call another value. So now you get back 1, 2, 3, 1, 2, 3. What is it complaining? Throw error. Oh, I'm trying to run the wrong file. Why is it called, it's supposed to be called currying. There we go. So now we get 22. So essentially this is currying. We have created the ability to have a function that returns a function. Then we can call that one. Give it the next value. Add 3. Give it the next value. Like you could do it this way, right? And then you could say console.dir add 3, which is a function that takes the final value. No, it doesn't. Add 3 is not a function. Oh, I didn't make any of these functions. Let's see, that's that. So yeah, add 3 is not a function. Add 3 is just the result of the other function. So we still get 22. But you can see, like, this is, what's the point of all these intermediary assignments? There's really no reason for them, which is why a functional programmer will almost always prefer code that looks like this, which might look strange to you. If you do Lisp, this starts to look really, really natural. Console, or I guess closure, or small, whatever, the different versions of scheme, things like that. Okay, let's see where we at. Currying, what is a pure function? I almost feel like this doesn't need code. Pure functions are functions that don't modify anything outside of themselves. Pure functions are the only good kind of function in my worldview. So here's a pure function. Here's an impure function. What is the difference? The impure function will modify things outside of itself. When you call this, it's going to modify this, which was defined up here. Therefore, by any definition, it's a side effect. A pure function does something like this. Pass in the I, return an I plus 1. So this one doesn't modify the state at all. It gets a value in. It doesn't use closure to get the value. It gets the value in. It doesn't modify anything outside of itself. Now you could have something like let well, I guess we can do a const here. Let const b equals 2, and then you could totally do something like that. We're modifying this inside of here. It's not a side effect. We're not returning a reference to this outside because it's the value object, so it's not a side effect. It's a pure function. Pure functions take their arguments in and they just return a value out. If 90% of your stuff is pure functions, your life will be easier as a programmer than if 90% of your stuff is impure. In fact, the very first lesson I learned as, like, I don't know, a 10-year-old kid or something in my first computer class was side effects are terrible. Side effects are evil. Now, we use side effects all the time in JavaScript because of closure and other things, but you only use them when you have to. You don't just throw side effects all over the place. Or at least you don't if you want to keep a job, be able to show good code to get new jobs, not fail clients, not fail jobs. How do you redeclare variables in switch block without an error? I don't think you should redeclare variables in switch block, but you would just put a let at the top and use closure. What is the reason to choose to name let as a keyword? Because it follows the proper scoping rules. It follows the strict rules. What is the temporal dead zone? I would imagine that this has to do with the time between when you instantiate something and then it actually gets set. I don't use nulls. I have a feeling this has something to do with nulls. Temporal behavior when declaring a variable with let or const, right? But not with var, right? And if you access it before it, if you access it before, because of the rules of scoping and the rules are strict, you get undefined here normally, but you get a reference error as soon as you put in let, as soon as you have strict mode, basically. And the time between like instantiation and when you can actually access the thing, anything inside of there is that dead zone. Back to the top. What is an EFI? EFI. Immediately invoked functional expression. It's not a fifi. That's how men handle themselves when there's no women around. This is an EFI. It's kind of weird looking, right? Let's break it down. This is a anonymous function. This is a function called EFI. If you were to do this, you would have to create the function and then you'd have to call EFI. And I see this code all the time in people's code, where they say, okay, console.dir EFI. If you run this, you don't get back anything. If you put the EFI in, or if you put the call to it in, you get it back. What if you don't want to have an assignment? What if you just wanted something like that? Well, you can't do that because you have to turn this into an expression first. So you can see now when we run it, when we run the file, this function runs automatically. The function runs automatically because we turned it into an expression. For those people who think they have to use an arrow function to have an expression, it's not actually true. You can totally turn a regular function into an expression. We've been doing it for years before we actually had arrow functions. Or, you know, I mean, if it floats your boat, you could write it like this and not have the assignment for a name at all. It's truly anonymous. It's a truly anonymous EFI, and it still works. So whatever floats your boat, if you want to pass a value in here like hello, you would then be able to get your value here, and then you could pass that value into here. And you still have an EFI, but now you have an EFI where you can pass stuff in. So you get an EFI. You get an EFI. Everyone gets an EFI. That's an EFI. What's the next question on the list? How do you decode or encode a URL in JavaScript? Kind of told us how already. Encoding.js. What they're talking about is something like this. You got https:// me.u.com, me.u. I don't need a .com. Me.u. Actually, let's just do localhost. You got this localhost thing. Maybe it's running on 3000. Maybe it's running on 80. It doesn't matter. And you've got like some URL. And then maybe you have favorite color, but maybe it's like this in your code. Favorite color equals blue. that is not a properly formatted route or a formatted URL, because there's characters in it that it's not going to like. Maybe you have blue house. Now you got a space in there. You've got this hyphen. There's all kinds of stuff in here that are not friendly to URLs. Okay, so how do you encode this? Right? What we need something like this. Some sort of URL encoder. Do we get it for free in Node when we're not on the browser? Well, we can use the URI. Is that a namespace? Maybe it's not. Find out. Live by the edge, baby. Live by the seat of your pants. Nope, doesn't work. That's what happens when you live by the seat of your pants. So URI does not exist. I don't know if I have this inside of outside the window object. URL encode on the server side on Node. Okay, so it's just the same thing. I thought it was going to be different. They lied to me. Encode URI component, pass in the URL. That's not the right file. Then you get the encoding. So what I want you to notice here is that it's encoded the entire thing. But that's not what we're going to want, because this is how like you would pass this as an option to like some parameters. Maybe it's like a callback URL, right? Like you're going to go to one place. You have to pass the callback URL in the get, so it's in the URL. And of course, you can't have all those special characters. So that's why you would use something like this. So probably what I would do is I would separate out this part. And I would say this is the params, or I guess you could call it a query, because that's really what it is. And then I want to do something like this, URL plus. And what will happen is it's going to just encode the part that we want. If I cannot be an idiot. So now the HTTP localhost like /URL, like that part's not URL encoded because we don't want it screwed up. But then any of this weird stuff that happens afterwards gets encoded. Now the problem here again is we've encoded the wrong thing. We've encoded this, which is not what we want. So how about this? How about we switch this to an object? Put that in quotes because it's got that hyphen in it. Let's change this to a string like so. I just like writing vanilla JavaScript. I could do this class all day. So we have two parts. We have the query, we have the actual like thing. Actually, you know what? I don't like that. Let's just do an array. Let's say the query is an array of objects. It's an array of objects. We got favorite color, blue house. So how would we append those? Well, we probably want to do something like the URL plus the stuff that's after, right? So query, actually, it's an object. Yeah, it's an object in an array. Query.map. Each of those is going to give us a param. We could then take the param and we could return it. We could say, okay, we want to return. Actually, that would be key and value. We would want the key like this, right? So let's put it in here inside of a string template. We're going to call it key so that we get actually the key printed out. And then we're going to have our equal sign. Actually, that's correct. Then we're going to have our equal sign. And then we're going to include our URI component, which is the value. Run this again. Oh, we have to join this thing now at the end. So each of these things have to be joined by an ampersand. undefined, undefined. This is, you know what, maybe it doesn't like query each one as an object. Well, if it's an object, oh, but it doesn't have keys. The key is this. So query.map, that's going to give us a object, which I should be able to destructure. But the thing is that the key is actually this, which is fine. We should get the key there, but I didn't get that. All right, fine. When I'm dealing with this sort of thing, here's what I would do. I would turn this from an expression into a block. Remember to put your return in there, otherwise you'll be very sad. And this is going to become what? Object dot favorite color, right? Sometimes I wonder if I actually should put that array in there with this. Dynamic keys are kind of a pain in the ass. Like, they can totally work, but the thing about dynamic keys is they're dynamic. So they're a lot harder to debug. But basically what I'm getting back is I'm getting back this object right here. I want to know what it looks like. Here's how I would do it. JSON.stringify. JSON.stringify is going to ensure that it stays as a string so we can see what's going on. Value is not defined because it's going to be object. I'm just going to take that to a string. Okay, so here is our thing, and you can see that it's we stringified it, right? So that's why there's strings outside of here. So it is just an object. So couldn't we just call object.keys would give us the keys, right? Okay, so here's our keys. But couldn't we just destructure this? Couldn't we say we want to destructure it into the query? What do we have here? We have the key and the value. And that would be destructured from the query that we're working on, which is the object. Our key should be here now. Our value should be here now. Undefined, undefined. So it still doesn't like that key. It still is not there. Console.dir key value. So it's not destructuring our stuff. Undefined, undefined. So it's not destructuring. Interesting. Why doesn't it destructure that? Not JSON. What about a type of object? It's just going to tell me it's an object. Object. So it's a type of object. So what happens if we did something like object at the index of, we already know what the key name is. So let's just put that in there. Okay, blue house. So we're getting that. I think we're going to have to map over the keys. So object.keys. We're going to map over the keys. There's only one of them though. I guess there's only one. So if there's only one, that would be the key. Now we have the key. We can get the value from this by doing object at the. So now you get URL, favorite color, blue house. You can see that this is now URL encoded. I'm going to be linking, putting all these Git repos up and linking them in the description. And every time I do a new day with the same topic, I'll update it. And then you guys can get used to doing get fetches and get resets to, like, you know, keep it up to date. So git push, actually git commit -m